Couple more seconds to finish writing, and then we can move on. Okay, going on to the next slide. So now we can use this definition to more clearly understand what it means to reflect a whole shape. So kind of like yesterday, we're going to go through a few problems where basically I just want you to watch. You don't really need to copy anything. Just watch. And then at the end, you guys are going to have an assignment to do on your computers, just like yesterday. So here's the first one. We're going to draw the image of triangle ABC after a reflection across line L. Okay, so they already did the first point for us. And what I'm going to do also is just write down all of my coordinate points. So if you actually want to write something, this is something you can write down. So let's go ahead and just, oh wait, this one does not have, I forgot, this problem doesn't do it on the coordinate plane because there's no numbers. So we're just going to do it with our eyes. Okay. They already did point A for us. And the way that they figured it out was by drawing the perpendicular bisector. So notice, line L is what we're going to reflect over. So what they did was they figured out how far is it from A to the perpendicular bisector. And then we're going to copy that same distance on the other side. And that's how we get our final point. But the most important thing is to remember that it's going to be a right angle. It has to be perpendicular. So I can do the same exact thing now with point B. I look at point B. It's not going to be perfect because I don't have a protractor with me, but I'm basically going to draw a line that is perpendicular. So you want that to be a right angle. And then I'm going to estimate and draw my second point about the same distance. So I want these two distances to be equal, and I think that's going to be just about right here. So that's my second point, B prime. Then I'm going to do the same thing with my last point. I'm going to draw a straight line that is perpendicular. And then I'm going to try to get it so that it's equal on both sides. So to go from C to the middle, I want it to be just about the same. And I believe that's going to be, let me see, 1, 2, 1, 2, just about here. There we go. And that's my C prime. Then I'm going to connect my 3 dots. And boom, I've got my final triangle. So you guys are going to see that on the homework tonight, you have problems kind of like this one where there's no coordinate plane, there's no numbers, there's nothing else. You just have to count and visualize and try to do it only by looking. So that's kind of the challenging part about this, is that there's not really any math right now. I'm literally just using my eyes. So do I have any questions so far? All right, I'm gonna delete all of the extra stuff so that you guys can more clearly see just the image and the pre-image. Does that look pretty good? Did I do a good job? Cool. And I always, sometimes like I have my iPad, right? So I'll flip the iPad around so I kind of see it in more straight. Like right now it's kind of crooked. So I'll always kind of like either tilt my head or flip it around a little bit so that I can see it more straight. Okay, I'm gonna skip this one because it's the same thing and I don't wanna bore you guys too much, but I'm gonna do just number 6 because that one's a little bit interesting. So what's different about number 6?
The shape is like on both sides.
Yeah, so the line of reflection is passing through my shape. So when I reflect the shape over this line, it's going to look a little different than the ones we've been doing, because now some points are going to go to the other side and then other points are going to go over to the other side. So basically, what do you guys think? Point A and point B, they're going to end up where?
On the side where point C is?
Yeah, they're going to be somewhere. It's not going to be exact right now, but somewhere over there. But then point C, is it going to stay where it is, or is it also going to flip?
It's gonna flip.
Yeah, so point C goes the other way, and it's going to end up somewhere over there. So basically, it's kind of like the whole shape is like turning around, like kind of like, you know how the Earth has an axis that goes right through the Earth and it spins around that axis? It's kind of like that. So you kind of have an axis down the middle, and the shape is rotating around that axis. So I'm going to do it now a little bit more exact. So I'm going to start by drawing my perpendicular line. So from point A, I'm going to make sure it's a right angle as perfectly as I can. Let me see. That looks like a right angle. Same thing I'll do 1 point at a time. And then I'm going to try and make it as equal as possible on the opposite side. So I'm just kind of using my eyes, but it's going to be like somewhere over here. What do you guys think? Is that good? Maybe a little. You can tell me if I'm wrong.
I think that's good.
Okay. So I'm gonna leave it there. Now I'm gonna do the same thing with point B. I try to get it as perfectly as a right angle as possible. So to me, let me see. Like that. That looks kind of good. Now notice, what do you guys notice about my 2 black lines?
They're perpendicular.
The
Or
2
parallel.
black, yeah, they're parallel. So that might be something that we notice. We'll see if that's the same case with point C. But okay, now I'm gonna count. So it's like 1, 2, 3, kind of 1, 2, 3. It's like somewhere over here. Does that look okay? Cool.
Sure.
Sure. All right, let's do our last one. Point C. Now we're going the other way, but we're still going to try and make a perfect right angle. Hold on. If it will let me. Whoa. It doesn't want to make a line. There we go. And that's pretty good. But now I'm going the other way. So let me draw my new point. I want to make it as close as possible. And I think maybe around there is good. Okay, so I've got my 3 points. Everything has been reflected. Now let's go ahead and connect. And in just a second, I'm going to delete all the black lines, so it's going to be a little more clear. Let's see how that looks. How does that look? What do you guys think? Good?
Miss Lopez, I thought it was gonna be like slanted, not like.
Right, so it might be hard to tell because it's a little bit crooked, right? So if you turn your head and look at it so that the reflection line is straight up and down, see if that helps you to visualize it. I literally I'll take my laptop and I'll flip it around so that I can make sure I'm doing it correctly. And notice how my line of reflection is passing perfectly through these 2 points. Right? So that already shows you that I think I did a pretty good job because my reflection line is going through the points. So with this type of problem, which you will have on your assignment, it's all about looking carefully, visualizing everything, counting squares if you need to count squares to just make sure that your reflection is equal on both sides of the reflection line. Okay, so these problems are like easy because there's no math, but they're also kind of hard because you really just have to use your eyes. So do I have any questions on this type of problem? Okay. All right, now we're gonna use some math. So these are the rules when you're reflecting specific types of reflections. So notice in those lines were like random lines. Like these lines did not have an equation. They weren't any of the axes or anything like that. They were just random lines, random shapes on a random grid. They didn't have any specific numbers. But now we have specific rules whenever you're reflecting across the x-axis, the y-axis, the line y equals x, which we'll talk about, and the line y equals negative x. These rules, just like your translation rules, must be memorized. Must.
I have an excuse. I have a really bad memory.
Too bad. You better memorize, girl. Matter of fact, before your next test, I'm gonna have you guys do a quiz of just definitions and rules.
I have an excuse.
No excuses.
I have an excuse.
No excuses.
No, I have
I
a
don't
really
wanna
good
hear
Computer
it.
blew up.
I do not want to hear it.
My computer blew
I
up.
do not want to
Wait.
hear it.
I have a really good excuse. The guy on the street says that I will get amnesia tomorrow when he clogs my head.
Well, even then, you still have to have these memorized. So no excuses.
I
So
have a bad excuse.
write them down. Take 2-3 minutes to write them down. Take a picture, memorize. Go ahead. 3 minutes. I'm giving you a whole lot of time to write them down. The thing is, they also follow a pattern. So you will talk about the pattern in a second. See if you can figure it out while you're writing them down. Got 1 more minute. Give me a thumbs up when you're done writing. Good. Alejandro's done. Perla's done. Janelle's is done.
When you're trying to find excuses to not do the homework, so you cut off your arm. Get Nate.
Don't know what that means. Jalen, Tyrone, Emily, finish up.
Yeah.
You're done?
Yeah.
Emily's done? Okay, perfect. And if you didn't get a chance to finish everything, we're going to go through each of these, so no worries. Now, did anyone notice any patterns while they were writing?
When the y is feeling negative, the x is feeling positive, and when the x is feeling positive, the y, I mean, the other way around. You get it, right?
Yeah, okay, I got you. So, okay, so notice when I reflect over the x-axis, which one turns negative? The y, exactly. When I reflect over the y-axis,
How do you say X in Spanish?
X.
Yeah, X.
Okay, so there it kind of goes opposite, right? When you reflect across the x-axis, it's the y that changes. When you reflect across the y-axis, it's the x that changes. So that's a nice little pattern. And then what about when you reflect across the line y equals x? What happens?
Y equals fx.
Yeah.
Oh,
So what happens? What's a quicker way to say that?
I'm confused.
Don't worry about what's happening. Just worry about the pattern. What happens in the third scenario?
They get
Oh, they switch.
They switch, exactly. They flip. And then what about in the last one?
They flip and both become negative.
Good. So I call this a double flip.
Double whammy.
Double whammy, double flip. Okay, so in the first, and when you reflect across the line y equals x, the two values flip, they switch. When you reflect across the line y equals negative x, not only do they switch, but they also turn negative. So it's a double flip. So let's see what all of this means. Let's go ahead and we're going to do 4 problems. One is about each of these types of reflections. Okay, so like I said, you're going to do a lot of watching, but if you want to write something down, you can write down all the coordinate points. So that's what we're going to do. So in this example, we're going to reflect the figure across the y-axis, okay? So go in your notes, what is the rule for a reflection across the y-axis? Alejandro, what happens when you reflect across the y-axis? You just wrote it down.
When you refer across the y-axis, they change. I think. Yeah, no, they don't change. Y-axis becomes negative.
Careful, not the y, but the.
What?
Look carefully.
You say hyperbole?
I said look carefully.
Oh no, it's not. It's the x turns negative.
It's the x that turns negative, exactly. So this is in the top section, I'm writing just my general rule. My general rule is to go from A to A prime. So from any point to the image, you'll have to make the x negative. So in my top part, I'm just writing the general rule. Now I'm going to follow that rule and write down all my answers. So Emily, for m prime, what am I going to write down?
-1.
-1.
Oh, I called on Emily.
Oh, okay.
She said it though. Good job. -1, comma 2. For n
Call
prime,
on me. Call on
I
me.
already did.
No, call on me.
Jalen, what should I do for n prime?
You say my name?
I did.
Okay. All right. Is the what's your name? What's your name? What is it?
You know what? I'm gonna steal the answer.
Let him struggle.
Wow, that hurts.
Come on.
Perlo now.
That hurts.
All we're doing is changing the x to a negative. So what do I do?
-1,
That's
comma
it.
4.
That's it. Tyrone, what do I get for p prime?
Let me struggle.
Tyrone. Tyrone, if you're in your room, I'm gonna
Alejandro, please.
I don't-
Don't forget we're being recorded. Tyrone, we're changing the x to a negative, man. It's not hard. Come on. Thank you. -3, comma 3. That's it. It's as easy as that. So all I did was change the x to a negative. Now I'm going to draw my pre-image and my image. So I'm going to start with my pre-image. 1, comma 2, that's m. 1, comma 4 is n. And 3, comma 3 is p. Now, if I'm flipping it over the y-axis, which quadrant is it going to end up in?
The fourth one? Wait.
Janelle's had it, 2. Yeah.
This one.
Remember, it goes 1, 2, 3,
Oh,
4.
I was going.
You were going the other way.
Yeah.
It's flipping over the y-axis. So let's see if that's what we got. M is -1, comma 2, n prime. Then -1, comma 4, n prime. And -3, comma 3, p prime. That's exactly what happened. Okay, so the y-axis was my line of reflection. All I had to do was change all my x values to negative or to the opposite. So if you're going the other way, if they were all originally negative, then you would change them to a positive. You're just flipping the sign. That's all it is. Any questions on reflections over the y-axis?
I'm Gucci.
Okay. Perfect. Let's do another one. Now I'm going to reflect this quadrilateral, because it's got 4 points, quadrilateral, over the line y equals x. So this line, the line y equals x, is the easiest thing to see because look at everybody, eyes on my screen so you can see what I'm doing. I'm literally drawing this line right here, the one. What can you notice about this line?
That cuts through the middle, like.
Yeah, it kind of cuts through the middle. It goes through the origin, right? And look at what it's doing. It's passing through each one of these perfect points all the way down. That's because the line y equals x is an equation. What is the slope of that equation?
One.
Wait,
Yeah.
we have to pick 2 points.
The
Oh,
slope,
how about a say?
this one's easy because you can just see it. It crosses through each box, right? So the slope is 1 and the y-intercept is
0.
0. So it's kind of like y equals 1x plus 0, except you don't need to write the 1 and you don't need to write the 0. So that's why we call it y equals x. So you can just remember it as the one that goes diagonally, perfectly diagonally, y equals x. So that's the line that we're going to use to reflect. And what happens, who wrote it? Let's see, Daniel, what happens when you reflect across this line? What should I do to each of my coordinate points? Make sure to unmute yourself. You can look in your notes. We wrote it down.
What was the question?
So I'm gonna reflect all of these points, D, E, F, and G. I wanna know what I need to do with them in order to reflect them over y equals x. So we just wrote down those rules, and in those rules, it tells you exactly what to do. Would anyone like to help Daniel out?
I know.
Okay, Janelle's, I'm gonna give Janelle's a chance because she hasn't spoken or said yet. Janelle's, what should we do?
You flip the x comma y, so it's y comma x.
Exactly. So x comma y is going to become y comma x. So let's go straight down. 2 comma 0 becomes 0 comma 2. 2, 2 stays the same. 5, 2 becomes 2, 5. And 5, 1 becomes 1, 5. All we're doing is flipping. This is our flip. So we have to make sure this has to be memorized, you guys. All right. Now I'm going to draw my two figures, starting with the pre-image. I have 2 comma 0, 2 comma 2, 5 comma 2, and 5 comma 1. There we go. And now I'm going to draw my image. So I have 0 comma 2. Then I have 2 comma 2, which is the same. So notice point E was on that line of reflection, so it just stays where it is. E is the same as E prime. Then I have 2 comma 5. And then I have 1 comma 5. And there is my image and my pre-image. So if you're having trouble seeing the reflection, like I've been saying, rotate the whole, rotate your head until you're looking at it straight, up and down. That way you can visualize it a little bit better. Do I have any questions on this type of reflection?
No.
Hey, what about the angle reflection?
What about the angle of reflection? So reflections don't do angles. Angles are for rotation, which we're going to do tomorrow. So no angles, it just flips right over. All right. So that's what it looks like when it reflects over the line y equals x. Now let's do one over the x-axis. So I'm going to write down all of my points first. And what is my rule? X comma y becomes what? Let me ask
X comma negative y.
Jalen, good job. I was going to call on you anyway.
Oh, okay.
Since I'm flipping over the x-axis, the pattern goes, my y is going to flip. So I had S was 3 comma 4. Perla, what's it going to become now?
3 comma negative 4.
Good.
3 comma negative 4.
T was 3 comma 1. So Daniel, what's it going to become?
It is going to become 3 negative 1.
Mm-hmm. Exactly. We're just flipping that y. And then I'll do the last one. V goes from negative 2 comma 4 to negative 2 comma negative 4. That's our pattern. Now I'm going to go through real quick, and I'll start with my pre-image. So 3 comma 4 is my S. 3 comma 1 is my T. And negative 2 comma negative 4 is my
Miss,
V.
everybody says you forgot the letter U.
Thank you, Emily. I didn't
Emily's
even
saving the
notice.
day.
I didn't even think about like how weird it was that it would have been STV. Like alphabetically, there's definitely a U there. There we go. That's why I keep you around, Emily. Okay. So this becomes negative 2, negative 1. Alrighty. So that's right over here. Negative 2 comma negative 1. Or sorry, my original one is negative 2 comma positive 1. There it is. Okay. So I have this big ol' quadrilateral. Remember, quadrilateral just has 4 sides. Quadra means 4. All right. And this is going to be flipped over the x-axis. So what's going to happen is my image is going to end up, this was similar to one of the problems we did before, it's going to kind of like flip onto itself. So you're going to see that the points that are above the line will end up below the line, and the points that are below the line end up above the line. So everything kind of flips over itself. So let's see if that's true. I have 3 comma negative 4. That's my new S prime. Then I have 3 comma negative 1. That's my T prime. Then I have negative 2, negative 1. That's my U prime. And then I have negative 2, negative 4. Wait, something's up. What did I do wrong, guys?
Let's see. Miss, why did you make... Oh, wait, never mind. Wait, what did you do?
I don't know.
I actually see what I did wrong, which is that I wrote down the V wrong the first time. But I'm actually gonna, I'm just gonna keep going with what I have, because it's more interesting anyways.
Wait, what do you mean you wrote it wrong?
So I put the V in the wrong place, but I'm gonna keep it where it's at and just keep going. So just ignore.
Wasn't it a positive for the first time?
Yeah, it was, and I accidentally put it in the negatives. So, but I'm gonna keep it there
Oh,
because it's more interesting anyways.
oh.
So this 2 comma 4 ends up here. All right, now let's look. And there's my image. So notice, again, I always recommend literally turn your head all the way or turn your laptop so that you can see it. Oops. So that you can see it with the line going straight up and down, because it's going to help you see where that symmetry is. You're going to be able to see the left and the right and how they look the same. Any questions on reflections across the x-axis?
Miss, that looks like the X from X Factor.
Yeah, it does a little bit. You're right. Okay. One more. This is our last one. And now you're going to see what a reflection across y equals negative x looks like. So let me go back really quick. Y equals x goes up, right? This is a positive line. Y equals negative x is going to be the same thing, but going down, going negative. So what that looks like is this. Let me draw straighter. Hold on. That was bad. There we go. So this is my y equals negative x. Just because instead of going up, it's going down. This is a negative slope, but it's the same exact idea. So let's see what happens. What's my general rule? Let me ask, who hasn't spoken in a bit? Emily. What's going to happen to my coordinates?
Negative y comma negative x.
Good. This is my double flip. They switch places and they become negative. So let me make sure I don't forget any letters here. I only have 3, okay. So I go from -4, -2 to what, Perla?
Positive 4, positive 2.
So it's going to turn positive, but at the same time, remember, it's a double flip.
Oh, so it's 3.
So instead of 4, 2, I'm going to get 2,
Oh, yeah, it is a double flip.
Comma 4.
4, exactly.
Oh, I'm dumb. Sorry, Miss.
You're good. Double flip. All right, Tyrone, what do I get for B? I start at -1, -1. What's B
You
prime going
end
to
up
be?
with +1, comma +1. Since they're both ones, they don't change places.
Exactly. And then for C, I start at -1, -4. And Alejandro, where is it going to end up? For my final.
It's gonna end up as 4-1.
Good, 4, 1.
Yeah.
Perfect.
I'm gonna eat something.
All right, now let's go ahead and let's graph this. So starting with my pre-image, -4, -2, -1, -1, -1, -4. And which quadrant is it going to end up in? Anyone can answer this one.
Is it quadrant 1?
Yeah, quadrant 1, exactly.
I stole my answer. Oh my god.
Oh my god.
Miss, everybody's stealing my answers today. They're really and they're messing with it.
Or you just too slow.
I'm so dumb. What?
He said you're too slow.
I'm offended.
All right, so there's my image, A prime, B prime, and C prime. And again, tilt your head, tilt your screen so you can see it straight on and make sure that everything lines up correctly and makes sense. Any questions on the rules? Any questions on the 4 types of reflections? Anything
No,
else?
I could leave this microphone on and not make any sound due to the fact my baby sister's not here.
Oh, she's not here.
Yeah, she went with my mother.
It's good to have a little silence sometimes. Okay. Now, here's the last type of thing. I'm going to do a couple of challenge problems. I think just 2. No, 3. Okay. But these, honestly, I'm going to tell it to you right now, these are harder than what's on your tests. So this is going to be real challenging, but you can still do it because y'all are smart. Can I have a volunteer read the problem?
I can read.
Go ahead,
wait,
Pearl.
Daniel, you wanted to read? Okay, go. Wait.
Or not.
Okay, I'll just read that.
Go for it.
In the figure, point K is the image of point J under reflection across line L. Find each of the following.
All right. So we know that point J is our original and point K was the reflection. Okay, so we went from J to K, and line L is my line of reflection. That's all they're telling us. We don't know anything else. But we know some stuff about reflections that we learned today. So we can, because we know some stuff, we can fill in more information on this diagram. So what do I know since I just put down my reflection line? Let me actually make it a little bit better. Okay. What else could I possibly write down or figure out? What other information do I know?
Isn't it the reflection across the line y equals x?
There's no graph, so there's no coordinate plane right now. So this is kind of like one of those first questions we did together where it's just in the middle of nowhere. So that's not going to help us out.
Okay, at least I tried.
You tried, you know. That was a good question. What do we know about reflections? So what has to be true about J and K?
It has to be even.
It has to be even, exactly. So we know that from J to M, the midpoint, this distance has to be the same as K to M, the other half, right? Because the line of reflection cuts everything in half. It's a perpendicular bisector. That's the key information. So now we can create an equation, because what are we looking for? We're looking for JM. I want to know the length of line segment JM. And I know that JM has to be equal to what?
To MK
To MK, exactly.
or KM?
Or KM. Whichever direction you want to say it in is the same. Those have to be equivalent. And we know, based on the graph, that JM is 2x plus 4. And MK is 4x minus 6. Right? That's just from the graph. So now I can take that information and I can solve for x using algebra. So let's do that real quick. What do I do first?
Subtract the 4x. Wait, oh yeah, to the left, because you say to the left, to the left.
To the left, to the left, exactly. We're going to subtract. So 2 minus 4 gives me negative 2.
And then we subtract.
And then we subtract, 4, because we don't want them there anymore. So I'm left
Then
with,
you divide.
yeah. And what's negative 6 minus 4?
Negative 10.
And then I divide like Tyrone just said. Wait, why did I just write 6? That was weird. I had a 6 in my head for some reason. Okay. And my final answer, I get x equals
5.
5. Exactly. So I got the value for x, but I'm not done because I want to know the length of JM. So if JM is 2x plus 4 and x is 5, I can plug that 5 in and get the answer. So I know JM is 2x plus 4. So I'm going to plug in my 5. And what do I get?
14.
14. So JM is 14 units. So see how there's a way to mix algebra and geometry in one. And that's why it's really important to keep up those algebra skills. Because you, like I said, this probably won't come up on your test, but you never know, right? Don't take my word because I don't know what the test looks like.
We're talking about the ELC, right?
The EOC, yeah.
Okay.
All right, now let's do the other one. Now we need to find the value of y. And it's kind of hard to see what this is pointing to, but in the diagram, it's telling you that this right here, that angle, is 3y minus 30. Well, what do we know about that angle based on what we know about perpendicular bisectors? Or let me break it down. What does the word perpendicular bisector tell me? I'll break it down even further. What does the word perpendicular tell me?
That it's a cross?
So it's a cross. It makes that T, right? But what type of T does it have to be? Could it be any angle in the world? What type of angle? Like, if I drew these two lines like this, would that be perpendicular?
No.
Why
It
not?
It has to be like a plus or an X.
A plus,
It has to be straight up and straight across.
straight up, and straight across.
Yes.
What type of angle is that? What type of angle does that create?
A right angle.
A right angle, exactly. That's what I was trying to get at. And how many degrees is a right angle?
90.
This is 90 degrees. So in our actual diagram, even though it's tilted to the side, but if you tilt your head and you look, you'll see that these two lines are perpendicular, which means that the angle we're talking about is how much? We know they're perpendicular, so what do we know about that angle?
It is a 90.
It is
Right.
It's a right angle. It's 90 degrees. So this 3y minus 30 has to be equal to how much?
90.
90. Has to be equal to 90. So we can solve for y and get our final answer. What do I do first?
Add the 30.
Add the
Add the
30.
30.
Daniel, what are you doing with that?
30
Is that
plus
a knife?
30 plus 90 gives me,
120.
and I finish off by
Dividing.
dividing. 120 divided by 3 gives me,
4. I beat
Oh
you.
wow.
I beat you.
oh, it was y, not x. Y equals 4. And do I have to do anything else, or is that my final answer?
We were solving for a Y. So I
Mhm.
think that's our final answer.
So that's my final answer. Okay. So this is a really good question because it really blends together geometry and algebra. Do I have any questions about why I came up with any of these equations or anything like that? Okay. Let's go ahead now and do one more. This one's a little bit longer, but can I have a volunteer read it out loud for us? Tyrone, you want to read?
Sure.
All right, go ahead.
The figure shows the angle PQRS and its image after a reflection across the y-axis. A student said that PQRS could also be mapped to its image using the translation x comma y and x
Becomes.
becomes x plus 6 comma y. Do you agree? Explain why or why not.
All right. So just like I'm going to kind of reiterate, but basically it's showing us a reflection across y. So that's what it's showing us. And the question is, can you get the same exact image? So this is my image. Can you get the same exact image by doing a translation instead of a reflection? So if I use this translation rule, could I get the same image? So I want everyone to look and think about it for a minute, and then we'll discuss. Do you get the same image? I see Perla already put her answer in the participant. So if you want to click on participants, you can vote yes or vote no. And Perla says no.
Ms. Lopez, do you want something from the dentist?
No, I'm good, thanks.
I could bring
What
a
is that on your
toothbrush,
head?
a steel one. What?
Stop the cap. Stop the cap. What's on your head?
What I got for
What's
my
on your
birthday?
head? Today's not even your birthday.
All right, Jalen, since you are loving to talk right now, Jalen, you can answer my question. What does this translation rule mean in real words?
What does it mean in real words?
So tell me, where am I going? Up, down, left, right? How many units?
You're going to the right. Is that 2 or 4? I think that's 4.
Where do you see a 4?
I'm retarded. Hold up.
I'm talking about my rule, the one that I have written down. Not the graph, but the rule.
I can't. My brain.
Somebody else then. My translation
Please, my
rule
brain.
is the one that I highlighted and the one that I wrote down. What is that telling me to do?
6 units to the right.
6 units to the right. I know that because I see x plus 6. So that tells me I'm going 6 units to the right. So my question is, in the image below, like this graph below shows the reflection. All it's showing is the reflection. If I did a translation instead, would I get the same image? Vote using the participants button. Vote yes or vote no.
Wait, how do you do that again? I forgot.
Click on participants.
Go to participants.
What was the question you asked?
I'm asking the same question that it wrote down. Do you agree? So do you think that if I did a translation, I would get the same image? If I did a translation instead of a reflection. This is the image I have right here is a reflection. Okay, so I have 3 no's. I need a vote from everybody. So if you haven't voted, Daniel, Alejandro, Emily?
Miss, what do you vote?
I don't vote anything. I'm the teacher. Alejandro, what do you think? Daniel, what do you think? I need y'all to vote.
Does a thumbs down count as a vote?
You can use the thumbs down, that's fine. Okay, so you all vote no. All right, so you all vote no. Can I have a volunteer explain why not? Why not?
For a law.
You all voted no. You should be able to explain why not. Let's go.
What I did was like move each point like
Because
6
P.
to the right.
Mm-hmm.
So when you move P 6 units to the right, it lands on 1, 2, 3, 4, 5, 6. Let me make sure because I don't want to get this wrong. It lands where the point Q is.
Okay, perfect.
I'm sorry.
That was very, very nicely said. So if you did a translation instead, and you took each point and you moved it 6 units to the right, P would end up where Q is. Q would end up where P is. S would end up where R is. And R would end up where S is. So your new image, even though it lines up, even though it looks like it's lined up, that is a different image because the points, the name of each point is different. P is not the same as Q. Even though they look like they're in the same place, they're not the same because we gave them a specific name and we have to stick to that name. So when P ends up on top of Q, that is not the same point. Those are different points. All right, so the correct answer, good job, was no. They do not do the same thing. So that's a very important thing to keep in mind. If you are, even though the two kind of are on top of each other, it's like if I don't know, if I had like a red triangle, kind of like one was red and one is orange and the other one is green. They're not the same. They're different. They look similar, but they're different. Okay. Okay, let's do this very quickly. Last one. This is a select all that apply, and I got a little bit cut off, but basically it's saying, which of the following transformations would map the triangle ABC to a triangle that intersects the x-axis? So which of the following transformations will result in an image that also intersects the x-axis? Okay, it's going to be select all that apply. I'll give you 1 minute to look at it. We don't have a lot of time. I don't want to leave too late. Okay, like I said, we don't have a lot of time, so let's just quickly go through this. What type of reflection is A? Is it a reflection over the x-axis, the y-axis, y equals x, or y equals negative x? Good, y-axis. And if this triangle is being reflected over the y-axis, will the image cross the x-axis?
Shouldn't.
So if it's jumping over this line, will my image also cross the x-axis? Somebody else, yes or no? Visualize the image. I'm not going to draw it yet. Visualize it. Will it cross the x-axis?
I think no.
I think no. Anybody else? Agree or disagree? Okay, I'm going to draw it. Every point is reflected across the line. So it's going to look something like this. Oh, maybe that was somewhere over here. Doesn't have to be perfect. Does that cross the x-axis? The green triangle, does it touch the x-axis? I see a lot of blank faces. This is not good. Okay, yes, it does. You guys always like disappoint me in this class. I don't know what's going on. Okay. B. Like, I don't want to make this boring, but you guys make it boring. It's not me. What type of transfer or what type of reflection is this? B.
Over the x.
Yeah, this one's over the x-axis. Okay. When it crosses the x-axis, when it reflects across the x-axis, will the image also cross the x-axis? Every single point gets reflected. Janelli says, yes, I think. Okay.
I don't think so.
Okay, so I'm going to move. My B goes over to go from above to below.
Oh wait, never mind.
C goes over to go from below to above. So this was B prime, C prime. And then A was 3 points below, so now it's going to be 3 points above. Does this green triangle cross the x-axis?
Oh no, right? Because not all the points.
But does it cross the x-axis?
Oh wait, yes. Sorry.
Yes.
Mine is done.
It's okay, I know. We're getting to the end, but you guys need to keep it going because we got to finish. Okay. Now I'm going across y equals x. Okay, this does not want to draw a line. Come on. There we go. Okay. If I reflect over this line, will it be crossing the x-axis? Or in other words, where's it going to end up?
Wouldn't it end up in I forgot what it's called, but 2?
Quadrant, yeah, quadrant 2, exactly. So it's going to be something, I'm again not drawing it perfectly, but probably something like this. Does that touch the x-axis?
No.
No, it does not. It does not touch the x-axis. Okay, so we found the first one that's not correct. We're almost there, 2 more. Next, for D, we're doing a reflection over the other line, y equals negative x. And I know that because it's a flip and a switch. What about here? Visualize it, turn your head, flip it over. Am I going to be ending up touching the x-axis?
I think it's gonna be on the y.
You think it'll be on the y? Okay, let's look. So this is going to end up like over here. Something like that. And does that touch the x-axis?
No.
No. All right, last one. Point E, or option E, what type of transformation is this? Is that a reflection? No, what's that?
A transition.
Translation, good. And I'm translating, I'm going in which direction and how many units?
They're going upwards 1.
Good, up 1 unit. If I move that triangle up 1 unit, will it still touch the x-axis?
I think it will.
Let's see. B,
So you're going up.
A, C. Yes,
Yes.
Yes. There you go. All right. I'm sorry to rush through that. I'm sorry to get annoyed, but I mean, I keep saying the same thing over and over. Like, we had a whole thing planned and we didn't get to it. Too bad. I assigned homework already. It's up already on Khan Academy on reflections. So you have yesterday's homework is due on Wednesday. Today's homework is due on Thursday. And you'll get one more tomorrow that will be due on Friday. And that's it for the whole week. So you'll have 3 total. And they're always going to be due 2 days later. So you'll have homework due tomorrow, Thursday, and Friday. Any questions before we go? Okay. All right, I'll see you guys tomorrow. I'm going to put up the video at the end of the day. So make sure if you get lost or confused during your homework assignment, you can go ahead and watch that.